Good afternoon, Jan.
Hey, Michael. That's a long time.
It has been. Well, glad to see you back, but sad to hear that you weren't able to go on your trip.
No, no.
Mm.
It was good that I canceled it.
Mm.
If I would have gone, I would have been in big, big trouble. But okay.
Uh, yeah. Well, yeah, glad you caught it
No,
in
no,
time then.
no, no. My wife will be back tomorrow, so but it means I'm back a week earlier
Hmm.
than thought. Yeah,
Yes.
you have to be lucky in life from
Uh,
time to time, and I'm always lucky. So
at least so far.
yeah, I will continue to have luck.
Yeah.
So,
Excellent. Excellent.
so I saw. I did have my email, so I saw coming in a lot of new changes in GitHub.
Hmm.
Uh,
Yes. Yeah, I was focusing on yeah, some defect fixes um, and a logging feature that the improving team was really wishing for. Like, we want to see
okay.
what's happening under the covers.
Mm.
Can we get some logging? So,
Logging on the database then.
yes, yeah, particularly the client side. So,
Okay.
so yeah, you could see within um, yeah, within the app, or within the Android logs, or the um,
Mm.
um, iOS has a different name for it, but yeah, you could see the things that were happening within the application, and made it a little bit clearer what was going on, and then when you ran into a problem, what the problem was.
Yeah.
Because there's this interesting tension between reporting to the developer that something's
Mm.
going wrong and protecting the user from transient errors. Things go wrong. You want the user to just have a smooth, offline first
Mm.
experience. Give them the indicator that, hey, there's something wrong, but we're working on it, and
Mm.
they don't care about the actual error message. They care about, is there something I can do to help? I mean, yeah, I know that I'm walking around the city right now, so
Mm.
my connection is going to be poor. But then I can go into a coffee shop and connect to their Wi-Fi and
Mm.
fix the problem. So
Mm. I didn't catch up on the previous sessions yet, so perhaps you spoke about that.
actually, I've not.
Okay.
One of the defects that I fixed did pop up on a previous session. So
Mm.
yeah, I can show what that was, and show the fix for that one. Um, kind of
Yeah, but
kind of
the
interesting.
things the things you spoke about in the previous sessions, I can just see them
Yeah,
on YouTube, to avoid that other people are hearing the same story twice.
yeah,
But so the logging is completely new.
yes,
Hmm?
yes,
Okay.
yeah. So yeah,
And
I can
that's
pull
a
that
logging
up.
that is always enabled, or you just have to increase the level if you want to.
You do have to configure it. It's a
Hmm?
um, yeah, it's an additional line. So if you've already configured logging within your application, then it's one more line in order to let the general client do that same thing.
Okay.
So I can show you what those lines look like.
And that logging goes into the local database or into a text file, or it is synchronized back to the server, to the
It
replicator.
goes into a local file. Yes.
Okay.
Um, so in order to enable the logging, I use first of all Microsoft Extensions logging. So that's the interface for it. But then I also installed Metrolog. So this is
Mhm.
a UI that allows you to see the logs on the device. Um, So to set that up inside of your Maui program, you've got the logging builder inside of the app builder, and so then you can use these come from Microsoft extensions logging. You add in-memory logging, file stream logging, console logging. So you've got various options there, and yeah, I'm curious about trace logger. So I'm sure that that there's an option for logging in such a way that you can then send it up to a centralized log aggregator once you're connected. So I don't have any of that turned on in the example app, but for a production app, I think I would want to do that. So then for each of these, you can set up the options. So the minimum and maximum log level. So these levels go all the way down to trace. That's the lowest one. And in fact, I do log some things at the trace level. And that's, I'm opening up this HTTP connection. I received some some bytes, so it's like really low level. But then during this, I kind of designed things to work well at the information level. So it kind of tells you an overall story at the information level. So if minimum level is set to information or lower, then you will see that. So we log to memory, and we log to console, and then also to a file. So I gave it the name of a file. Given the name that I gave it here, I wonder if this is this one actually comes from MetroLogger, but some combination of those two. And
better make it.
Yeah.
Better call it Jinaga then, no?
True. Yeah, let's go ahead and if I look for Metro logs elsewhere, I don't find it. So I'm wondering. Yeah, let me keep it as Metro logs for right now and make sure that I've got both sides of that equation. I'll bet you that it would work. It's probably using this folder path for the other side. But so yeah, you set that up, and then your builder will then add some services for logging. So if I go, for example, to the let's go to the site list view model. This one right here. Then we'll see that here we can inject an iLogger of site list view model. So it sets up the IOC in order to resolve iLoggers for a particular context, a particular category. And that allows you to then configure different categories at different levels. So if you want to turn up logging on one particular class or one particular namespace, you can do that. And so this is still the Blog Maui application, so I'm just using the logger within the application to keep track of things. So in this case, actually just looking at exceptions. But what we really want to do is kind of peer under the covers and see what Jinaga is doing. Now, Jinaga does not assume that you're using IOC. So here in Jinaga config, this is where we create the Jinaga client. And this, by the way, is called, I'll bounce back to what we were just looking at. This is called right here, or that function is registered as the creator for a singleton. So the first time that you need a Janaga client, it's going to call the function and it will keep that singleton around. So, so that means by the time it calls it, it's got all of the things that are registered inside of the service provider. So we can use that in order to get the iLogger factory. And so right here where we create the Janaga SQLite client, we set the logger factory option. So that is a new property on options that lets you set up logging. So once you do that, then the Janaga client will distribute that logger factory to its various components in order to make sure that they can log to however you've configured it.
Okay. So actually, inside Jinaga, you don't need to adapt anything. It's in a universal way implemented.
Yes. Yes, this iLogger factory comes from Microsoft Extensions Logging.
Mm-hmm.
And so it could be configured using the Metro logger, could be configured using Serolog, whatever whatever extra things you need to be able to attach to it. So within the application, there's one other thing that it sets up that is really neat. So here we also configure the log operator retriever. And that comes from Metrolog, and that gives you some extra capabilities. One of those capabilities, I'm not seeing it directly here, but one of those capabilities, which I set up in the app shell view model, I think, is shake to bring up the logs. Yeah.
Okay.
Yeah. So we grab the log controller, and then we can turn on shake to navigate to logs. We also have a command that will take you to the log page. So on the Android emulator, there's no way that I could find to simulate a shake of the device. I even tried.
You take your monitor.
Yeah.
You take your monitor and shake it.
Yeah. I data mine that command.
Yeah. Is on the three dots on the right of the screen.
Mm-hmm.
Is there no shake command there?
There is not. There is this not virtual sensors. There is an accelerometer option. Well, I thought there was maybe that was on the iOS emulator, but there on one of the two, there's an accelerometer, and you can move these. Device pose. That's it. Yeah. So you can move these sliders in order to move the device. So I was like, can I shake it? No, that doesn't actually simulate a shake.
Okay.
That's just so you can, if you've got an app that uses the accelerometer for something, then you could test it out that way. Which, by the way, one of the apps that I've wanted to do for a long time is a swashbuckling app. So it's a game that you could play by holding your phone and waving it around like it was a sword. I mean, it's probably going to break phones. Yeah. So, but yeah, imagine that if the feedback was all audio, because you can't see your phone while you're waving it around, and maybe some haptic. So maybe you could hear which direction the other blade was coming from. I don't know. So yeah, that's how you would test your swashbuckling app. So yeah, instead of shake enable, which works perfectly fine on the physical device, so that's good. I also had this data bind this command so that we can go to the log page. And
You see the specifications.
Yep. So it is logging in inverse order here. So it pushes new entries to the top, which really works well for the device. In the console, it pushes new entries to the bottom, which really works well for the console. So you get the experience that you need. So you can see here that it has stopped an observer. That's because it navigated away from a page. And so this is the observer that was running. And so we can see that it was looking for all of the sites from a particular user. And then for each of those sites, looking for the domains and names. So that's the specification that's inside of the site list view model. That one there. So it took that link, compiled it to a specification, and showed you what that specification was. So very helpful. That kind of grounds you in where you are in your application. And then the other things that it shows are that you are reading facts from SQLite, that you're fetching from the replicator. So these are really high level, I'm going there kind of things. And then we see here where it started the observer. So not too much detail in between. So I started the observer, read some facts locally, and then I did the fetch. It turned out I needed to fetch from 7 different feeds in order to satisfy this one specification. We can actually kind of count the feeds within the specification. And then that fetch completed after 1.6 seconds.
Okay. But that's what we get on info level.
Yes.
Yeah.
Yep. And so yeah,
Yes.
the beginning there.
If you put it on debug level, you would see even the SQL that we sent to SQLite.
I don't think I logged the SQL. I logged that we were calling SQLite. But yeah, this was the only place where I took, I took a block of generated text and included that in the logs. The rest of them, I even try not to do any, identifiers or anything like that. Keep the logs safe. Yeah. So yeah, I haven't. We'll try upping the log level and see if we can get that to work. When I tried that on my laptop, for some reason it didn't do what I expected, but we will try that real quick. And then here, share logs. This is a really useful button because you can take the log file, it zips it up, and then you can drop it to Google Drive in this case, email it to somebody. And on my phone, I can actually just airdrop it to my laptop and open it up right there. So so share logs is pretty useful, and so this whole experience right here is part of MetroLogs. So they just give you this page for free.
That's great.
Yep, quite useful. So let's try to adjust that real quick. Go back here, and so I'm interested in the memory logger. So let's drop that to trace. And see if that makes a change. Yeah, when I tried before, I just tried the console logger. We'll have to look at the console and see those logs happening. So since we're here, output is where you'll find the console logger. So all that's coming out. And yeah. Okay, so if we view logs now, then Yeah, we're still seeing the same level of logging here.
Yeah.
So that's interesting. Let's play around with it. So if we change the console minimum level to trace, then I'm expecting that I should see more information show up in the trace window, or in the console window, even if it doesn't show up in the app. So we have, see if I can recognize some. Yeah, so you see the word trace show up here. It's showing you, this is the log factory showing that it created a logger, which, funny enough, it logs at the trace level. But it doesn't look like I'm seeing trace logs from Janaga itself.
Did you log anything with at trace level?
Yes, and we can go back to that code and see where that is. So like here's the network manager logging at the information that fetch completed. And this one we recognize as that's the observer, starting the observer, and that's at the info level. So I'm not seeing the traces here. And then, of course, we wouldn't see them here because anyway, we didn't see them last time. So, okay. And then one last place to try before we switch focus would be in the file logger. You can set options dot minimum level equal to log level trace. And sure, while we're at it, set the maximum level.
And we didn't exchange the minimum level and the maximum level?
Yeah, the minimum should be trace and the maximum should be critical.
Okay.
Yeah. Yep. So just try one more time. It certainly is chatty for other things happening.
It was trace.
Yeah, so one of the logs that I would expect to see is something that's saying that it's hitting this particular URL. So I do include the URL that it's trying to hit, just in case you wanted to diagnose it and it's like, I'm not getting the behavior that I expect from the replicator. Which replicator is it again? That one. So, yeah, I'm still not seeing the trace. So let's well, there is actually one other thing to check real quick. Which version of Janaga.net am I using? So let's manage the, oh, that's right, I'm running. I can't manage NuGet dependencies. Okay, manage NuGet packages. And we have
11.
We have Janaga 11.3. Yep. 11.4 just has the fix from last week. So I'll upgrade to 11.4 in order, after I show you the issue. But in the meantime, let's go ahead and not create a new project, but let's Why am I having such trouble with the keyboard? Okay, we'll do it with the mouse. Okay, Janaka.net. So in here, let's take a look, for example, at the HTTP network. I think this would be it. Well, let's make sure that I've got the latest code on this machine. Yeah, no, I'm way behind. Okay. So build, but yeah, you can see here we're passing through the logger factory. So HTTP connection uses this logger factory. And so it creates the HTTP connection logger. And so we can see it's still got to build that stuff, but like right, yeah, here we go. Right here, we do a log trace to say that I'm making an HTTP call. So get or post. Here's the base address / the path. It does a log trace whenever it re-authenticates. So it calls back your authentication method in order to refresh the token. So then there's a couple of places where we do more than trace. So of course error, but then actually this one is just errors and traces. Yeah, because this is way down deep. So yeah, the my basic line of thinking here was that at the top level, I want to trace the information because this is what I'm trying to do, and then down deep, that's where I do the traces. So it's like these are the details of how I'm doing it. So when we talk about things like the fact manager, that's a good one to look at. So here in managers, we've got the fact manager. So it grabs the logger factory. And then actually it might be one level. Yeah, it just uses that to talk to observers. Okay. The observer definitely does some of this stuff. So in the observer, we use the log factory in order to create a logger. So we've got a logger of observer. Yeah, so here we've got information when we start an observer for a specification. So that's the big one that we saw, the big old descriptive string for that specification.
Okay.
Yeah. And then when you call stop, we say observer is stopping. So we've got that at the at that low level. Other calls to, yeah, that's not working. So to find the other calls, and if we just start from the top, the Janaka client, then I know that we will find them. For example, if we do a query, come on, Janaka client. There we go. So we've got all of our different query methods. Yeah, the different query methods call run specification. And so that's where we see a query starting for a specification. And so then the query was able to run on the graph, meaning that it just looks at predecessors. So you already have all the information you need here. It doesn't have to hit anything. Or the query did need to call something and it succeeded after so many milliseconds.
Okay.
So yeah, I basically it went through top level and looked at the different the different paths that that you might typically call, and then made sure that they log at the information level to kind of tell the story, what that's all about. And then you went, all the way to the bottom level and said, okay, now I'm hitting HTTP and I want to log out the specific details of how I'm doing that. So I did log traces down there. So then, I was able to test it. How did I do that? How did I make that work?
You saw the traces also, or no, or just the
Yeah,
information?
while I was building. Oh, I think maybe I think maybe the way that I did it is I just used log information everywhere, and then once I saw it working, then I switched the detailed ones to log trace. I might not have actually seen them work as log trace. Yeah. So I'll have to dig a little bit more into that. See see why we're not able to turn on the tracing within the application. So that gives you some logging, a little bit of help there. Prior to that, the way that I would do things is I would put a breakpoint inside of on status changed right here. And so whenever an error happened, for example, I would get notified here. But
that's only as long as you are in developing mode.
Yep. So then I relied on just the logs that I put into the application itself in order to help me diagnose on device after doing a deployment when I wasn't connected to a debugger, which can be kind of limited. So, for example, you look at the site list view model, and so here we set up our specification, and then we do a Janaga client.watch. So it immediately returns an observer before hitting SQLite, before hitting the replicator. So if an exception were to happen, it's going to happen later than this. This monitor method I put in place so that I could await these two tasks. And those tasks, they will throw an exception in some cases. So cached will throw an exception if there's something happening when it tries to load from SQLite. But then as soon as it's done with that, it's not going to throw. And then loaded is only going to throw on the kinds of exceptions that you don't expect to happen just naturally. If you lose connection and it just keeps retrying and then it finally gets a connection back, loaded is not going to throw an exception. In fact, loaded resolves after the first batch of facts come back. So if loaded is successful, then that means that it was able to call the replicator and get something back, and then it's resolved. But the observer is still going. Well, it's still going if you have used subscribe. That's right. If you haven't used subscribe, then yes, the observer is still going, but it is no longer connected to the replicator. So it loaded from SQLite, it loaded from the replicator, and now it disconnected. And then if anything else happens within this application, then we will get notified via this callback here. We'll get those new projections. But until we switch watch to subscribe, we don't get we don't stay connected to the replicator anymore. So at any rate, it's not guaranteed that you will always get your exceptions by listening to those two tasks. So in order to report exceptions to the user, then we need to have the event on status changed, and in order to receive connections, in order to see them as a developer, then we'll want to turn on logging. So that was a nice quality of life change there. So I'm pretty happy with the story that it tells when you just look at the logs. One of the stories that you can see is that navigating away. Okay, good. We saw the other thing that I wanted to talk about. When navigating away, you stop the observer. So when you're navigating to a pop-up, I want to keep the observer alive, so that, because you're going to go back. And so you should still have all of this data here. What you didn't see is while I was... interesting. Okay, good. Oh, very interesting. Okay. Yeah. Let's see if that one has been fixed too. That might have been fixed kind of accident. But what it's saying is that what the animation was hiding from you was the fact that while the dialog was open, the list was empty. And then when you navigate back, it creates a new observer and populates the list again from the SQLite database. So by the time the list is revealed behind the animation, it looks like it's been there all along, but it really hasn't. You can see that better when it does the side-to-side animation. So I do want to fix that, and that behavior is plainly visible inside the logs. But this is showing you a little bit about the problem that came up last week. And that problem was that after 4 minutes of subscribe, the observer would throw an exception. Okay. The reason for that... Now, here we're looking at new code, so here we're looking at code that's already been fixed. But if I go to the observer right here, then...
Didn't we have a problem in the past that he closes the connection after 4 minutes or something?
Yes. And the close the connection after 4 minutes and reopen is by design, but it's not supposed to throw an exception when that happens. So when I start an observer, I use fetch from network. I pass keep alive in there. So keep alive is going to come in and it's going to be true, and then I call fetch. There we go. So yeah, if I'm using keep alive, then I'm going to call the factmanager.subscribe. Otherwise, I just use factmanager.fetch. So fact manager calls the network manager. Network manager, where did you go? Subscribe. There we are. This creates a subscriber, calls start. It's doing some reference counting so that you can make sure that you don't waste resources. And then, so here we go. So this is using a timer to refresh the connection every 4 minutes. The idea being that HTTP connections are not intended to be held open for a long period of time, and so with server-sent events, you can get away with it for a little bit, but the routers in between they want to see these connections get cycled. Come on, what are you doing? And so you can't rely upon that connection staying open. And if the connection closes, if it closes nicely, you get notified. And that's how TCP works. You've got the fin that goes out and says, "Yep, I'm closing," but there's no guaranteed delivery on fin. I think it tries it retries for about a minute if it doesn't get the ACK. Maybe it's even just a retries twice. I mean, it's really not trying very hard to notify you that the socket closed. So you can't rely upon that. So you could be holding on to a socket on the client side that you think is still good, and the server is long gone. Mm-hmm. So so every 4 minutes, we cancel the cancellation token, and then create a new one, and then connect to feed with that new cancellation token. So that is supposed to set up a feed, and then it uses that cancellation token in order to cancel the various things that it's going to be doing. But one thing that, as it turns out, it was not able to use that cancellation token was this one right here, the network load. Let's go to the HTTP network. This network load. So here we're passing in the cancellation token, and we're doing all the right things with it. Passing it down to the web client, saying, "Hey, use that to load." It's not jumping to the right places. Here's load. And then at that point, it's like we've got nothing that we can do with it. So there was a point where I was saying, okay, I'm going to subscribe to that cancellation token, and then whenever it gets raised, I'm going to close the socket myself, close the stream that it's reading from, and then when I tested it, well, first of all, the exception that you saw is on Android. If you close a stream while another thread is reading from it, then it's not going to interrupt that other thread nicely the way that I wanted it to. It's going to throw this weird exception, and it's going to throw the exception on the thread that's trying to close the connection, not the one that's trying to read. So I can't even use that to hack an interruption. So that didn't work out well, and that was the first exception, the first error that we saw. So then I tried finding a nice way to actually close the HTTP connection, and HTTP client does not offer one. The mechanism that I thought I found, I tried it out, and actually nothing happened. I was able to set the cancellation token, and that is when you're using the stream. If you read from the stream using a cancellation token, the API is there, but HTTP clients streams don't honor that, and they just keep on reading. So I think that has to do with the way the HTTP client is meant to be used. HTTP is intended to be request response. So the client makes a request, it gets a response, and then the conversation is done. The server decided that the conversation was done. An HTTP client is able to reuse those sockets. So conversation done, I'll cache that for a little bit. If there's another request, I'll reuse that socket, and I'll make the next request on that one. But so closing from the client side just is not in the spirit of the HTTP client. So where I ended up, and so I will go ahead and update this package. So let's updates. Here we go. Janaga and SQLite. You can do it. I know you can. There we go. Okay. So so now we will run it with the fix in place. So what it will do now is it won't even try to interrupt the HTTP connection, because the server is going to close that connection after 5 minutes. So I want to see if maybe I should adjust those times, but 4 minutes for the client to start a new one, and then 5 minutes for the server to shut it down. So if everything is going well, then the client will get the fin, and it will return from read, see that the connection is closed, and it will stop.
Reconnect.
Yep. And it will have already reconnected a minute earlier. So there's that minute overlap that you've actually got two connections to the same feed.
Yep.
So maybe I'll adjust those. Maybe I'll even make them the same duration. It's not strictly necessary that you make sure that you never miss something. There could be a small gap, and that would be fine. Subscribe is just to give the user a more live experience.
At the moment that a new connection is made, can the client not just disconnect the old connection?
The problem is that we are inside of. Let's hop in here. HTTP connection. For some reason, this isn't doing my navigation right, but we are ultimately inside here. Observable stream. Right here. We're inside of readline async. Okay. So we are awaiting a method, and with .NET Standard 2.1, you can't pass in the cancellation token, but basically I re-implemented in one branch readline async so that I didn't have to use the stream reader, and I could use the stream directly. And then with the stream, you can pass in a cancellation token, and that's when I found this particular stream was ignoring it, and the contract says the stream is allowed to. So basically we're awaiting something that we cannot tell the operating system to make this a wait return. So it's just gonna.
At worst, we have two sockets at the same time.
Yeah. Yep. And so in the in the best case, you'll get that that notification a minute after you've created the parallel one. But in the worst case, then you won't get that notification at all, and then this will keep a task running within your mobile app. So, not thrilled about that. That's just one more reason that WebSockets would be a better implementation than server-sent events. So I do intend to implement WebSockets. I wanted to do server-sent events first because they're a good fallback. I can always do server-sent events. It's basically polling, except for the server is going to hold on to that connection for a little bit, but here that allows us to poll instead of at a 10-second interval or something fast so that the user thinks that it's alive. This allows us to poll at a 4-minute interval, but it's still effectively polling. So yeah, ultimately WebSockets, but yeah, in the meantime, these kind of parallel things. So I'm thinking that I always lose where that loop is. Yeah. I'm thinking that I will want to adjust the 4 minutes, wherever that ended up. I want to adjust the 4 minutes to actually make it 5 minutes. So that way, in the best case, you're cleaning up one task while you're creating another one. And so, in fact, if I make it a little bit longer than 5 minutes, then it will be possible for one of those tasks to get cleaned up. You back into the thread pool, and then you start the next one. So that might even keep the number of threads that it needs to a minimum. But yeah, so there's some adjustments to be done there. Yeah, not finding that code all of a sudden. But so now this has been running. Maybe I've been chatting for 4 minutes. Yep. So we can see that here we started the observer. Initially, we read those 9 facts from SQLite. We subscribed to those 7 feeds, passing those bookmarks, said, this is as far as I've read on these feeds. And so there's been nothing new on those feeds. And so we immediately receive 0 facts from each of those 7 feeds. And that initialization takes 4.2 seconds. Wow, that's a long time. The user didn't see that because they were looking at the facts that they just loaded from SQLite. So at least that's good. But wow, that is a long time for it to make that connection. And so, yeah, that's our 1447. We can see that activity happen. Oh, okay. No, I haven't been. Yeah, I haven't been talking for 4 minutes. Yeah, I was almost there, and then it stopped. So, if we let this go for 4 minutes, we will see the fix in the log. But yeah, so let that one go for a bit, and then see if I can find my way back to from minutes 4. That code right there. It's inside of the subscriber. Okay. So other ways that this code could be improved is right here, connect to feed. You can see that yeah, it is calling stream feed, which is a void method, and then it's got a couple of async callbacks. So it gets a callback whenever we've received new information from the stream. So we can load those new facts from the replicator. We can save them to the store. We can update our local bookmark, and then we can notify our observers. So we're getting this called back every time we learn about some new facts. And then there's also an exception callback. So so we get notified of any exceptions that are happening on this particular stream. And so some of the exceptions are recoverable, so we might actually get a callback and then keep going. And so we might get several exceptions on the same stream. So that's possible. But there is no mechanism here to notify us that we have closed the stream. And so that means that this call to connect to stream, let me double click here so I can see it over there. There it is. Oop. Yeah, so this call to connect to feed happening inside of this timer, there's there's no mechanism that I've built so far that can cause us to run this function again earlier than the 4 minutes. So that would be nice to be able to say, all right, the connection has closed now and we're done with it, so let's start a new one. So if I had that mechanism, then I might even bump this up to higher than 5 minutes, which is the server's timeout, the replicator's timeout. So if we...
But actually, it doesn't matter at that moment. The moment that the server disconnects, you're notified, you reconnect, and everything goes fine.
Exactly. Yeah. And so we've got that that 5 minute keep alive happening.
Yeah.
But yeah, if it goes longer than 5 minutes, if it goes much longer than 5 minutes, then you know that you're in that state where, you know, the server's gone, but I don't know about it yet. My socket's still open.
Yeah.
And then we can use the timer to start one in parallel, knowing that we can't clean up the one that that is still awaiting because it's awaiting something that we can't cause to signal. Hopefully, eventually, the operating system will, and it'll do all the cleanup.
Yeah. Another thing would be that once you're over the 4 minutes, you do some polling from time to time to see whether the server is still reacting on that connection.
Yeah, and that's one of the other problems with server-sent events. There's no more information that the client can send to the server. So it's still request response. The request is already gone, and the server's not listening anymore. And it's just, it responded with some, but it held the connection open so that it could respond with some more later. So switching to WebSockets would allow us to do exactly that. The client could say, hey, is this WebSocket still good? And send another ping from the client side. So that definitely will be a better experience. So some small fixes that I can do here, and some much bigger improvements that I could make by using WebSockets. Now, has it been 4 minutes? I should have actually looked at the clock before, or when I canceled it. But I think we were at about 8:50, my local time, when I opened it. They were currently at 8:57. So, assuming that we weren't looking at the logs for 3 minutes, I think we might be good to take a look at the logs now. So, view the logs. We see that it stopped, it unsubscribed. So, there we go. Now we're seeing some extra stuff happening here. So when we started, read our facts, subscribed to our feeds, got that information, or got the 0 facts, and initialized after 1.9 seconds. Better than 4.7, but still not great. And then, right here, you can see from 4:51 and 4:55, so 4 minutes later, refreshing connection to feed. And you see that 7 times. So 7 different feeds refreshed. And then we received 0 facts on those feeds in that time frame of 4:55 and 55 seconds. And then, so we don't see another initialized, because initialized is telling us that we've told the application that it's got fresh data. So if there was a spinner on the application, that's when the spinner disappears. So, so here we're just kind of seeing the heartbeat happen. So now it's able to run that heartbeat and not crash. And then we only saw it stop the observer when I navigated away. So, problem fixed.
Indeed, that's nice.
Okay. So, Yeah.
And the,
Still some.
and the only way to know about that is by the logging. So it's
Yeah.
great to have that.
Yeah. Very true.
Mm.
Yeah. Otherwise, it would just be, oh, 4 minutes has passed and it hasn't crashed, so it must be
Mm.
fixed. Now you
Right.
have proof.
Mm. Well, I think that's that will be a very useful addition to production once if you get problems, and the fact that they can just send it over by whatever means, by Google Drive, by email.
Mm-hmm.
Because you can make it automatic, that it comes automatically to a central server, but
Mm-hmm.
you never know. The problem might also affect that.
Yeah.
While if the user can choose, they put it on Google Drive, for example,
Mm-hmm.
to get it to their laptop, it will just keep it there until they have a connection again.
Yeah. Yeah. And to be quite honest, I only expect people that I actually ask to test an application, some beta testers. I would only expect them to go through that trouble. An end user probably wouldn't. So
For the end user, you should be able to ask the user to enable logging to a higher level at that moment,
yeah, there are
or
some.
to that from a distance.
Yes.
That you have an administration table, for example, that synchronizes. You can say, okay, that user enable logging.
Yep. And that's a problem that Raygun has solved. So I am happy to use Raygun for my mobile apps, and then direct app developers to use whatever tool they want to use for that purpose. But yeah, that would be a lot to build. Just to have add that as an add-on to Janaga. It's like, I'm solving this problem. Let people who have already solved that problem keep solving it.
So just by using the log mechanism in Microsoft, we have all that.
Yeah. Yeah. Exactly.
That's great. That's great. I will try to catch up this week on the on the lost, not the lost, but the videos that I didn't see. And then I started chapter 13. So 10 and 11 are still waiting, but the new stuff is more exciting than the old stuff.
Yeah. Yeah, I think so too. Yeah, I really enjoyed writing chapter 13. It's like, yeah, this is good. And in fact, I've already, even before getting back the tech reviews, I've already realized that there is a problem. So, in chapter 13, I talk about the inverse algorithm, and so whenever you go to the nested specification, so we've got let's get all of the blog sites, and then for each blog site, get the name and the domain. So those nested specifications. That top level one, all the sites, has where not deleted, where not restored. So it's got a negative feed and then a positive feed, if you think about it in terms of feeds. Kind of the same mechanism happens in inverses. Well, in fact, it happens in inverses and it doesn't happen in feeds because you don't have, anyway. The important point is that you will have a set of tuples that represents that a site has been created, and then another set of tuples that represents that it's been deleted, and then another set that represents that it has been restored. And so I call the created and the restored positive and the deleted negative. And as you go, where not exists, every time you do that, you switch from positive to negative. And so I said, okay, take all of the positive sets of tuples and then continue those with the nested specification. So I need to know about a change to the name or a change to the domain, if it has been created and if it has been restored.
Yeah.
But as it turns out, inverses don't have to do the same thing as feeds. They don't have to make sure that you don't that you read forward only, because feeds are intended to be read in that direction. But an inverse, it's now got a current state and it will notify. So whether it's because the site was just created or because it was restored, you are still in the current state of it positively exists. So having both of those inverses just means that you're notified twice.
Okay.
Which doesn't actually cause a problem, but if we can clean things up, say, okay, just take the top level as is, and then append the nested, and continue the inverse algorithm from there. So it cleans things up quite a bit.
It's not a mistake. It's just not as efficient as it could be.
Yeah. Yep. So yeah, I will revise it as such. I don't know if Sander would pick up on that. He already told me he's not really a mathematician, so he wouldn't be checking the proofs. But
I might not even not realize it.
But yeah,
I
want to get that dialed in. I want to get that just right.
Okay. No. Anyway, chapter 12 was a really nice chapter.
Excellent.
Quality as usual.
Fantastic.
So, okay. So I will have a look to chapter 13, and try to catch up on all the old videos that I missed.
Very good.
And then we see each other next week, Thursday, I assume.
Yes, that's right. And I believe that we have a time change between now and then. So, yeah, double check.
Okay.
I will update the the Google invite, since that's in UTC. But I will let you know for sure.
Yeah, we don't have a time change here yet.
Okay.
But okay, you guys are faster than we.
Yeah. Not a race I want to win. Don't even want to run it.
It's time that they stop changing clocks. That
Yep.
would be the most efficient.
Yes, indeed.
Okay, Michael, see you next week on whatever timing we will be there.
Yes, indeed.
Okay.
All right. Bye.
See you. Bye-bye.